In this video, we would be talking about environmental impact of manufacturing solar panels. Manufacturing solar panels, like any industrial process, has environmental impacts. However, it's important to note that these impacts are generally considered much lower compared to the environmental costs associated with fossil fuel-based energy generation over the lifetime of the solar panels. Here are some key environmental impacts associated with manufacturing solar panels. Energy consumption. The manufacturing process for solar panels requires energy, primarily from electricity. The energy intensity of producing solar panels varies depending on factors such as the type of panel, e.g., monocrystalline, polycrystalline, manufacturing techniques, and the source of electricity used. Raw material extraction. Solar panels are primarily made from silicon, which is derived from quartzite or sand. Extracting and processing raw materials like silicon, aluminum for frames, and other metals for wiring and junction boxes can have environmental impacts, including habitat disruption, water and air pollution, and energy consumption. Chemical use. Chemicals such as hydrochloric acid and sulfuric acid are used in the production of solar cells. While these chemicals are typically used in closed-loop systems to minimize environmental exposure, there is still a potential for environmental contamination if not managed properly. Water usage. Water is used in various stages of solar panel manufacturing, such as in cleaning processes and cooling equipment. Depending on the manufacturing facility and location, water consumption can impact local water resources, particularly in areas with water scarcity issues. Waste generation. Manufacturing processes generate waste materials, including silicon dust, slurry from cutting processes, and wastewater containing trace amounts of chemicals. Proper waste management practices, such as recycling and treatment, are essential to minimize environmental impacts. Transportation. Solar panels and their components are often transported over long distances, which can contribute to greenhouse gas emissions and air pollution if not optimized. Solar panels are primarily made using several raw materials, each playing a crucial role in the panel's construction and functionality. The key raw materials include silicon. Solar panels are predominantly made from silicon, a non-metallic element that is crucial for converting sunlight into electricity. Silicon can be either monocrystalline, high purity, single crystal, polycrystalline, multiple crystals, or amorphous, non-crystalline. Semiconductor materials. Besides silicon, other semiconductor materials like cadmium telluride, CDTE, and copper indium gallium selenide, CIGS, are also used in thin-film solar panels. These materials are less common, but offer different properties and manufacturing advantages. Metal frames. Aluminum is commonly used for the frame of solar panels due to its lightweight, corrosion resistance, and structural strength. It provides a stable support structure for the glass and solar cells. Glass. The top layer of solar panels is typically made from tempered glass, which protects the solar cells from environmental factors like hail, snow, and wind. It also allows sunlight to pass through to the solar cells. Backsheet. The backsheet of a solar panel is a thin layer of polymer or other materials that protects the backside of the panel from moisture and mechanical damage. Encapsulant. This is a special type of polymer that holds the solar cells in place and protects them from moisture and mechanical stresses. Ethylene vinyl acetate, EVA, is a common encapsulant material used. Bus bars and contacts. These are made from conductive metals like silver or copper, and they help in collecting and transferring the electricity generated by the solar cells. Adhesives and sealants. Various adhesives and sealants are used in the assembly of solar panels to bond different layers together and ensure the panel is waterproof and durable. These materials undergo complex manufacturing processes to create solar panels capable of efficiently converting sunlight into electrical energy for various applications. Despite these environmental impacts, it's important to note that solar panels have a relatively low environmental footprint compared to fossil fuel-based electricity generation over their entire life cycle. Their use significantly reduces greenhouse gas emissions and air pollution associated with conventional energy sources. Efforts are ongoing within the solar industry to improve manufacturing processes, increase efficiency, reduce waste, and minimize environmental impacts. As technology advances and regulations tighten, the environmental footprint of solar panel production is expected to continue improving. Thank you for watching. Have a fantastic day.